All right, you're going to want to hear this. We're talking about a scientific record, like a fundamental limit in computer science, that stood strong for over 65 years, and it just got completely obliterated. This is a story about speed, raw intelligence, and the hidden engines that, believe it or not, run our entire modern world.
Seriously, just think about it for a second. You punch in a destination on your phone, and instantly, out of literally trillions of possible paths, it just knows the single best way to get there. How in the world does it do that? Well, it's all thanks to something called the shortest path problem, and trust me, it is everywhere.
And this slide right here shows you just how crucial it is. I'm talking about the data packets that zip across the internet to your screen, the AI robots navigating a giant warehouse, even entire citywide transport systems. They all depend on finding the most efficient path. And for decades, there was only one algorithm that was king of the job.
To really get this, we have to go back in time and talk about a legendary algorithm. This is a piece of computer science so brilliant, it has dominated the field for over half a century. Its name, Dijkstra.
So way back in 1959, a Dutch computer scientist named Dijkstra cooked up this incredibly elegant way to find the shortest path between any two points in a network. It was revolutionary, and it just worked so well that it became the gold standard for, well, pretty much everything.
And you have to appreciate the timescale here. 65 years in computer science, that's an eternity. We've gone from computers the size of a room to supercomputers in our pockets. But through all of that change, Dijkstra's algorithm was still the fastest. It was the undisputed champ.
And look, this wasn't just, a popular opinion. This was the scientific consensus. For generations of computer scientists, it was a fundamental truth, a theoretical speed limit that pretty much everyone believed could not be broken. It was, simply put, the best we could ever do. Until now.
And this, right here, is where the story gets really good. After 65 years on the throne, the king was finally dethroned. That supposedly unbreakable limit, yeah, it was broken.
The breakthrough came out of a research group at Tsinghua University. A team led by Ran Duan developed a totally new approach. They looked at this classic, old problem from an angle nobody had ever really made work before. And what they found, well, it changed everything.
Just let that sink in for a moment. A record that stood since the dawn of the computing age wasn't just nudged a little bit, it was completely and utterly broken. This is a huge historic moment for computer science. So the big question is, how much faster are we actually talking here?
Okay, let's put these two head-to-head. We're about to look at the math that scientists use to measure an algorithm's speed. Now, don't worry, it looks a little crazy, but I promise I'll translate it into plain English.
All right, I know, this looks like a bunch of complicated math, but the idea behind it is actually pretty simple. These formulas, which are called Big O notation, just predict how much slower an algorithm gets as the problem gets bigger and more complex. For 65 years, Dijkstra's formula on the left was the best anyone could do. The new one on the right is a breakthrough because it grows way more slowly. It's basically a smarter way of searching that's way more efficient, especially when you're dealing with gigantic networks.
And that is the key takeaway. For a simple road trip in your car, the difference is going to be tiny. You'd never notice it. But when you're analyzing massive networks, like the entire internet, or global shipping routes, or maybe even the neural pathways in an AI's brain, this new algorithm is significantly faster. It's a huge leap in efficiency right where it matters most.
So, yeah, a faster formula is awesome for scientists. But what does it actually mean for you and me? Why should you be excited about this? Well, this is the part where this discovery leaves the research lab and starts changing the world around us.
Think of it like this. One of the most fundamental building blocks of all modern technology just got a massive upgrade. And that improvement is going to ripple outwards, It'll let the tech that's built on top of it become way more powerful and efficient. And that ultimately leads to a smarter, quicker world for every single one of us.
So all those critical systems we talked about at the very beginning, from the maps on your phone to the AI robots in those massive warehouses, and even the very backbone of the internet itself, they're all in line for a major upgrade. This isn't just a tiny little tweak, it's a foundational boost to the speed and the intelligence of our entire digital world.
So there you have it. A 65-year-old giant has fallen, and a new champion has taken the crown. It's just a powerful reminder that in science and technology, there really are no final frontiers. What we think is an absolute limit today might just be the next great record that's waiting to be broken. The only question is, which one's going to fall next?